Hello, welcome to the course of Computer Network. So today we are going to discuss about the wide technology. So in this chapter we are going to discuss about the Ethernet, then we will discuss about Ethernet frame structure, IEEE standard, Ethernet evolution, NIC card, and lastly we will discuss about the data rates. So starting with the very first, let's discuss about the Ethernet. So here the Ethernet is invented by Bo Metcalfe and it is a Ethernet network which is developed on May 22, 1973 to interconnect advanced computer workstation. So here the Ethernet is a network protocol referred as IEEE 803 protocol. So here the protocol has evolved and improved over time and now it can deliver speed up to gigabits per second. So here it was introduced in 1980s and then standardized in 1983 as IEEE 802.3. It is standardized by Digital Equipment Corporation, Intel and Xerox. So here it is a family of computer networking technology that controls how data is transmitted over a LAN and MAN network. Ethernet uses hybrid starburst topology to connect devices in the network, and Ethernet works on layer 1 and layer 2 of OSI model. Next, let's discuss about the Ethernet addressing. So here the Ethernet at data link layer is responsible for Ethernet addressing, hardware addressing or MAC addressing. So here the Ethernet MAC address are in hexadecimal format and it consists of 6 bytes, that means 48 bits. Here first 3 bytes tell the identity of a vendor and the last 3 bytes tell node identity. So here the MAC address is a unique code which is stored on network interface card or Ethernet card, and there are two types of MAC address. Universal administrated MAC address that is assigned to device by their manufacturer, that is burned in the card, and organizationally unique identifier, that is OUI. It are administered by the IEEE Standard Association. So these are the two types of MAC addresses. So here in Ethernet addressing, they are also known as the originally unique identifier, that is OUI. So here there are 6 octet. This was first, second, third, fourth, fifth and sixth. So this is 6th octet, and first 3 octet are originally known as OUI, that is organizationally unique identifier, and the last 3 octet are known as NIC, that is network interface controller specification. So here this OUI is further, the first octet is further divided into 8 bit. So here the first 3 byte tells about the manufacturer, and the first bit of the first byte, that means this bit of this byte is referred to as unicast if it is 0 and multicast if it is 1, and this second bit of the first byte is referred to as UL bit, that is universal local bit. So here it is identify how the address is administered, that is globally unique or locally administered. So this is about the Ethernet addressing. This is the MAC frame format of Ethernet. So here IEEE 802.3 used within the 10 and 100 Mbps system. So this is a Ethernet frame. So here the 7 byte is of a preamble, 1 byte is of SFD, 6 byte is of destination address, 6 byte is of source address, 2 byte indicate length, 42 to 1500 bytes are for data and padding, and 4 bytes are for FCS. So here the main function of data link layer is to convert bit into bytes and then bytes into frame, and it encapsulates the packet that are coming from network layer to frame and then transmit it to physical layer for transmission. So let's discuss about these fields one by one. So here first one is the header field, and here the header field contains preamble and it is of 7 byte and it consists of pattern of alternating ones and zeros, and this informs the receiving station about the start of frame and enable synchronization. Next is start of frame delimiter. SFD, this contain an alternating pattern of ones and zeros but ending in 2 ones. Another one is destination address. This contains the address of receiving station, and here the leftmost bit indicate whether the destination is an individual address or a group address. If it is individual address, it is indicated by 0, and if it is a group address, then it is indicated by 1. Then is source address. It is of 6 byte and it is used to identify the sending station. Then is length or type, it is of 2 byte and it give MAC address. So it indicates the number of client data type that are contained in the data field of the frame, and it assigns a unique Ethernet type hexadecimal 0x0800 for IP4 packet and hexadecimal 0x08DD for IPv6 packet. Next is payload. So here the payload consists of data and this contains the payload data. Its size range up to 1500 byte, and if the length of the field is less than 46 byte, then the padding data is added to fill the data block. The next is trailer. Here the trailer consists of frame check sequence, that is FCS, and it is of 4 byte. It contains a 32-bit cyclic redundancy check that is generated over the destination address, source address, length type and data field. So this is about the field of the Ethernet frame. Next we will discuss about the standards of Ethernet. So here IEEE 802.3 is a working group which defines the physical layer and data link layer MAC of wired Ethernet. Ethernet is defined under a number of IEEE standards, and each standard defines a different type of Ethernet. Each of the Ethernet IEEE 802.3 standard can be uniquely identified. So here 802.3A is developed in 1985 and it is used for 10 base 2 thin Ethernet. 802.3C is developed in 1986 and it is used with 10 Mbps repeater specification. 802.3D is developed in 1987 and it is used with the fiber link. And 802.3I is developed in 1990s and it is used with 10 base T twisted pair. And 802.3J developed in 1993 and it is used for 10 base fiber optic. And 802.3U is developed in 1995 and it is used with 100 base T fast Ethernet and auto negotiation. And 802.3Z now is developed in 1998 and it is used for 1000 base X, that is gigabit Ethernet. And 802.3 AC is developed in 1998 and it is used with VLAN tag. And 802.3 AE is developed in 2002. It is used with 10 gigabit Ethernet. And lastly, 802.3 AT is developed in 2005 and it is used with power over Ethernet link. So these are the standard of Ethernet. The next we will discuss about the NIC card. So here the NIC card stands for Network Interface Controller or card, and it is also known as Network or LAN Adapter Physical Network Interface. So here NIC cards are the computer hardware component or the circuit board which is installed to connect the computer to the computer network. So it provides the computer a dedicated full-time connection to the network, and here Ethernet cable is used to connect the computer to the network. So here the Ethernet cable is connected at this port. Next is Ethernet evolution. So the Ethernet evolution starts with thick net cable and it goes up to twisted pair cable. So the thick net cable are identified as 10 base 5 and it used NIC card and transceiver. So here a physical cable known as attached unit interface AUI connected a transceiver to NIC in a computer. Another one is thin net cable that is identified as 10 base 2 and it do not use NIC card or the transceiver. Here the thicknet integrate a transceiver directly on the network interface card and runs a coaxial cable from one computer to the another computer. Twisted pair cable, it use hub and the twisted pair cable. Here this is the third generation that use a central electronic device that is hub to separate the computer attached to the network, and here it use this hub to connect the computers with each other. The next we are going to discuss about the data rate. So here the 10 base T cable is known as twisted pair Ethernet and it gives the speed of 10 Mbps and it is rated as category 5. And 100 base T is a fast Ethernet and it gives data rate up to 100 Mbps and it is categorized as category 5E. And 1000 base T is a gigabit Ethernet and it gives a data rate up to 1 Gbps and it is categorized as category 6 cable. So this is all about the wire technology. Thank you.